Imagine, just for a second, being born as one type of creature. And then, right in the middle of your life, you completely dissolve and rebuild yourself into something entirely unrecognizable. Honestly, it sounds like straight up science fiction, doesn't it? But here's the wild part. It happens every single day, literally right in our own backyards. So how exactly does nature construct entirely different bodies in a single lifetime? Well, it's easily one of the most phenomenal magic tricks in all of biology. And today, we're going to unpack exactly how it all works.
Welcome to The Explainer. Our primary goal today is to empower you, the future educators, with the strict boundaries of biological transformations. We're going to master the stages of common life cycles and look specifically at the absolute shapeshifters of the insect world to see how these wild transformations actually happen. Okay, let's dive into this. Here is our roadmap for today. First, the universal build sequence. Then, the metamorphosis showdown. Third, complete metamorphosis explained. And finally, incomplete metamorphosis explained. Part 1, the universal build sequence, establishing the biological baseline. Before we can really appreciate nature's rule breakers, we have to ground ourselves in the baseline rules that govern all living systems. Basically, the build sequence is a predictable, time-dependent developmental loop that living systems progress through. Whether we're talking about a towering oak tree or a tiny house mouse, it's locked into this sequence. It's the foundational timeline for common plants and animals. And this brilliantly illustrates that continuous loop from birth to eventual decline. It's so elegant in its simplicity. Every organism goes through phase 1, growth, where energy goes primarily into just building mass and capability. Then, phase 2, reproduction, where the priority shifts to passing on genetic material. And finally, phase 3, decline. This continuous loop is essentially the standard operating procedure for life on Earth. Part 2, the metamorphosis showdown, the strict boundaries of transformation. Now, nature absolutely loves to put a radical twist on those standard operating procedures. As educators, you must master the strict structural and behavioral boundaries defining the two primary types of insect transformations. We want to clearly define these exact boundaries so you can confidently teach them to your own students. It's not just that bugs change shape, they follow exact parameters that fall into one of two distinct showdown categories. Part 3. Complete metamorphosis explained, the dramatic shapeshifter path. Now, what's really interesting about this process is that it has a highly definitive structure, consisting of exactly 4 entirely distinct developmental stages. We start at step 1, the egg. Then step 2, the larva. Step 3 is the pupa. And finally, step 4, the adult. Keep in mind, every single one of these chapters requires completely different environments, behaviors, and physical bodies. Let's really zoom in on the larval stage for a second. This is an intensive feeding machine. It's a period for intense feeding and growth that looks entirely separate from the adult form. It bears absolutely zero resemblance to its final self. Its sole biological purpose is to just eat, accumulating all the raw fuel and energy required for that massive structural remodeling that's going to happen later inside the pupa. To give you a really strong mental anchor here, our classic examples are butterflies and beetles. When you see a caterpillar munching on a leaf, you're looking at that intensive feeding machine, the larva. It looks nothing like the elegant, winged butterfly it's going to turn into. That 4-stage, total structural teardown and rebuild is the absolute hallmark of complete metamorphosis. Part 4. Incomplete metamorphosis explained, the gradual growth path. Let's move to and see how this builds. Because if complete metamorphosis is a dramatic shapeshift, incomplete metamorphosis is all about gradual development. Structurally, this path relies on only 3 stages. Step 1, egg. Step 2, nymph. Step 3, adult. Rather than dissolving and starting entirely from scratch, the organism maintains a consistent general shape from birth. The crucial differentiator here is the nymph stage. The nymph emerges as a smaller, wingless version of the mature adult. Now, because insects have rigid exoskeletons, essentially wearing their armor on the outside, they can't just stretch and grow like we do. So the nymph has to undergo successive molts, completely shedding its old exoskeleton to expand. It's basically a miniature adult that repeatedly has to upgrade its armor to scale up. Your concrete anchors to instantly solidify this 3-stage process are crickets and grasshoppers. When you spot a tiny grasshopper in the yard, you aren't looking at a larva. You're looking at a nymph. It already looks exactly like a grasshopper, just a much smaller, wingless version of the adult it will eventually become. So the crucial point is really putting these two vital developmental strategies head to head for maximum retention. On the one hand, you have the larval stage, intensive feeding, an entirely separate look and requiring a pupa stage to redesign the body. On the other hand, you have the nymph stage, a smaller, wingless version that relies on successive molting to gradually scale up. Mastering the boundary between these two is the absolute key to understanding insect life cycles.
To wrap up this explainer, I really want to leave you with a fascinating question to ponder. Why did nature engineer two distinctly different paths? What unique evolutionary advantages might each type of metamorphosis hold for an insect's survival? Think about competition for food, vulnerability to predators, and the sheer energy required to transform. Which path would you choose if you were designing an unstoppable organism? Take that thought with you and keep exploring the incredible biological machinery all around us.